Okay. So last week we have covered, okay, I hope that you are clear. Last week we have started the thesis writing. Okay, I have covered the general in the slides. Okay, and then we have discussed the abstract starting from the title, I think, starting from the title. What should be covered in the title, not too general, not too detailed, limitation of words. And then abstract, I hope you can still remember. If you don't remember, I haven't put it in the Putra Blast, but it is there in my YouTube. Okay. Right. This you should know what should be put in the abstract. Okay. The second one that we look from two examples, introduction. Okay, how you introduce, how you put your problem statement, objective, scope of study, limitations in chapter 1. And the most important is chapter 2, which is we discuss or we look through examples of how literature review is written. And I told you that literature review for thesis is, of course, very much more comprehensive compared to the proposal. Okay, so that is understandable. And the one that I'm showing you, of course, is PhD. Of course, it is looks a bit more complicated, but what I want you to observe is the style of writing. What should be in the each section. Okay. So as I told you before, okay, this subject is not really to test you, but this subject, research methodology, is to equip you, to help you with your master dissertation, whether you are doing it now or you plan to do it later. Okay, that's the purpose of this subject. But of course, assessment has to be done. So that's why you have all those assignments and you also have the final. Okay. So final exam. Okay. All right. Just a moment. It's not something that you have to memorize because it's going to be an open book exam. So it's more of you of writing. You have to find the information, write it down, make it into proper essay or sentences or discussion. Yeah. So there's no need for you to memorize things in this subject. Okay. But for you to understand and be able to write it properly on papers. And as you know, your assignment covers 70%. You have done by right, you are doing it 35%. And you have another assignment which we're going to discuss next week or probably preliminary next week, another 35%, and your final only 30%. So when you know by right, the assignment should be prepared properly. Yeah, you have done like in statistics, some of you have done some group assignment. For this one, personal assignment, because each subject has different what we call as learning objective, PO outcome that we have to measure. Some we have to measure your communication skill. Some we have to measure your what we call as you work together, your leadership skills. So that's why sometimes I requested that you have a video of how you conduct the meeting to prepare for your group assignment, because those things are needed for evaluation. Yeah, it's not just simply I requested because those with certain there are certain needs to have that assessment. Okay, so for this, it's more on critical thinking of how you write or present your ideas. And then of course, the proposal written part, okay, that gives you the idea of how to write. Well, I'm not expecting a long literature review, but at least you know how to go about. Yeah, all right. But yeah, there are two of you who had, I mean, discussed. Some of you has discussed with me. So I don't know for some of you whether you need personal coaching or I don't know. You can do it, then it's up to you. Yeah. Okay. Last week also we have discussed about method section, methodology, which is chapter 3. Okay. So there is an important link, okay, especially very closely linked to chapter 4. Because as a reader, for example, myself as a reader means that I evaluate the thesis. I have to jump sometimes from chapter 3 to chapter 4, chapter 4 back to chapter 3, because there are certain that I have to validate. Okay, what are the how do you conduct? Okay, I look at the results, and the result seems to like a bit baffled. So I have to look back at the method section. So the arrangement of method, chapter 3, methodology section, has to be properly aligned with chapter 4. Okay, so what I'm showing you right now. Okay, so I think I have shown you both examples have flowcharts, right? So from flowcharts, you can easily see. Okay. You can easily see the sequence of the study. So let's look at the first example. Okay. So the first example, right? Okay. We want to have, we want the reader to be comfortable, understand the story. So it's actually very important for you to draft the flow chart. Yeah. So in this example, you can see, okay, please try to memorize so that we can jump to chapter 4. The thesis started from, even though some terms that you don't understand is okay. It's about the biomolecule. Okay, so aptamer is a biomolecule. Okay, so this is what the thesis started with. And then there is some surface modification, okay, and surface characterization, followed by electrochemical study. Right, that will be part 1. So electrochemical study, clearly only covering a few parameters, does not cover a lot, okay. Now part 2, okay, for, the thesis started to discussion on the development of sensors, okay, which is the detection of tuberculosis by using 2 biomolecules. Okay, and I will show you another example, of course, that this is just example, but a lot on sensor part, electrochemical characterization, but just follow the discussion. And part 3, because actually it's just an extent from part 2, which is combination of those 2 biomolecules. Part 2 separately, part 3 combined. So remember this, and then we're going to jump to chapter 4. So what I would like you to observe is how the discussion is being carried out. Okay, and the flow of discussion. So here, you can see that the chapter 4 starts with an overview. Okay. The chapter 4 starts with an overview, meaning that, again, if you look at chapter 3 just now, there is a flow chart giving an idea of how the methodology throughout. And in chapter 4, you don't put flow charts, but instead you tell a story, sort of a summary, what will be discussed in chapter 4. It's good to have this because this will give a clear view what will be discussed further. Okay, let's see. Okay, firstly, the thesis described about the biomolecule, remember, similar to the chapter 3. And the biomolecule was reassessed in this case because the biomolecule is not novel, means it's not being prepared fully by the candidate, but it was based on previous study, but there is some reassessment being carried out. So here he told about there is an reassessment by using this technique called Ilona. And then remember about the flow chart just now? There is surface modification. So now we talk about there is surface modification for the sensor development. And the sensor surface or the surface modification is characterized using certain techniques. So in this case, we have FTIR. So clearly you should by right have FTIR in method section. Also in the chapter 4. You cannot have results, but there is no procedures or whatsoever in chapter 3. Same goes if you have something in chapter 3, but you don't have it in chapter 4. It has to be aligned. If you have the results in chapter 4, there must be a procedure. If you have a procedure in chapter 3, then there must be results presented in chapter 4. You cannot skip, right? So here, he has listed all the characterizations that he used to identify or to confirm the surface modification. So this is also something very important for you to know. Let's say in future you want to do surface characterization, meaning that you have done some chemistry on the surface and you want to confirm there is, the modification happens, whatever it is. So these are the certain characterization that you can do to confirm. One is, of course, FTIR, because we know FTIR can identify functional groups. Whenever that you do chemical modification, FTIR is a must before and after, okay? Because FTIR can show you what functional groups like alcohol, carboxyl, aldehyde, ketone that appear on the surface, whatever that you have done. Okay. So it's very important for you to know what kind of characterization required for certain procedures. Okay. All right. Another important is XPS. XPS is expensive. So it depends whether you need it. If you are working with like amine group or probably I'm not sure. I think amine, and there is another functional groups. There is another chemicals that can be clearly uh, shown or evidenced through XPS. I know is amine. There is another thing, but I forgot. Okay, contact angle is another easy to prove that you have done some modification on the surface. Because contact angle can give you evidence of hydrophilicity and hydrophobicity changes on the surface of the whatever surface that you are modifying. Okay, so these are the things that you can use. There are other things as well, like AFM. What is the name of the AFM in detail? That's also you can, if let's say you're doing some porosity, means that you put in some porous polymer on top of your surface. You can do FISM, and let's say you modify with certain nanosizes material, you can do HR temp. So you must be able to know what to present to evidence the steps that you have done, or the whatever that you want to present the evidence for. Okay, I hope that you follow me. Okay, so the next part is the part 2. Okay, so finally is the part 4. The next part is part 2 and part 3, which is presented in chapter 3. Okay, what I would like to show you, okay, I'm not going to show everything from this thesis, only some highlights. Okay, so this is not really important, but here, because the student is a he, that's why I mentioned he. He wants to highlight about the biomolecule. So he started to talk about the biomolecule. So this is not actually a result. Yeah, you can see this is not actually a result from an analysis, but this is very important. Okay, because for the reader to know about the biomolecule. You can also put this in chapter 2 actually, which is the literature. But depends, you can also put it in chapter 4, because that would like make it easy for the reader to catch up with the flow of the thesis. Okay, so you can see this is not results. Okay, this is not a result, but there is one important thing that he wants to highlight here. Okay, since this is not something new, okay, sorry, yeah, since this is not something new, but you can see there is a word adapted. Okay, okay, means that he clearly explained that the biomolecule is not his, but he adapted from previous work, and there is minor modification. So this one is very important. Telling the truth, telling what you have done. If it is originally no modification at all, then you just tell the reader that there is no modification, but he has done some modification, and it is presented here. Okay. So you must be able to draw with good quality. Okay, this one no exception. Whether it's master dissertation or PhD, everything has to be high quality in terms of figures, diagrams. Okay, and the font must be according to the format. Okay, and you can see caption. So this is what we call as caption. Must be very descriptive. Yeah, you cannot just say CFP10 aptamer secondary structure, because that doesn't tell the story. Okay, you must tell the whole story that is happening in this picture. So the story is CFP10 aptamer, secondary structure prediction, means this is a new modified structure, not the original one that the candidate has adapted. And the prediction or the new prediction is using M-fold. So by rights, the M-fold, what is M-fold is already explained in chapter 3 by right. Yeah? Because you cannot expect the reader or whoever the examiner has to search what is M-fold. It should be, has been explained in chapter 3. And you can see there is red lines here. It has to be explained. You cannot just put things here and it is not explained in the caption. So the red line marks the modification. So clearly now the candidate has indicate that this is the part that he has done some modification from the original structure, from the original sequence. So this is not probably important to you, but this is how you should write. If you do something related to this, you must be clear about which part, how to write it. Okay, this is one example. Okay, if you have any question, please just stop. Now, the second part is, remember about the word reassess. So he has done some Ilona just now. So I'm not going to talk about Ilona, but you can see from here. The first is about binding ability. Okay, so he wants to talk about the binding ability of the biomolecule. So you can see from the last discussion I mentioned about, you have to discuss your own results first, not about someone else's result. So clearly, he straight away go to figure 4.3, right? Which is, okay, one thing that I want to highlight. Once you mention, okay, the figure, you don't show the figure first. You have to discuss it in the paragraph first, mention it, discuss it a bit, then the figure should appear. You can see the figure is not that far away. It should appear after the after after it is mentioned. Okay, let me okay. PDF. Okay, so now, so I want you to observe few things. Yeah, one is, of course, you need to observe on the quality of the figure. Clearly, you need to have a very clean clean figure. Clearly, you need to have distinct colors, okay, to differentiate between these three. Okay, observe the y-axis, x-axis, the units. Okay, so this is something like you know, if you haven't done it, you might miss it. Okay, this is very important in thesis writing. The y-axis, the units must be clearly written. Yeah, this is something unacceptable if you don't do it, even though it's a short thesis whatsoever. Okay, now we look at the caption. If you look at the caption, okay, the binding analysis of the, if you have A, then you put A, and the way that you write also is very important to make it clear that, okay, this is for CFP10 and this is for aptamer to its respective target antigen. So the binding ability was compared with aptamer alone and non-target antigen. Okay, there is, okay. So this is something that you learn in statistic, right? Some of you has learned statistic. Okay, I hope that you know what it is. Okay. Okay. So this is something, there is something missing here actually. But I think it is labeled. Okay. So there is legend. All right. Okay. All right. Okay. So what I want to highlight here is the caption. Okay. The whole caption. must be very informative. Okay, the key is the diagram itself, the figure itself is self-explanatory. What does it mean, self-explanatory? I don't have to read the discussion. I can just look at the figure, read the caption, I can understand a lot. Let's say 90% of the story. So that is caption all about. It has to be, figure and caption has to be self-explanatory. It doesn't means that the reader does not really have to like look back at the discussion. Okay. All right. So, okay. So this is the discussion, right? It still has to be discussed, of course. Okay, display the result showing, this is how you, I'm trying to show how you discuss because this is binding, right? Okay, so how do you show there is binding? Okay, so here he described the absorbance value. Okay, because the results, if you look at it, is actually absorbance. So you have to discuss the absorbance. Okay, so a high absorbance value to its meaning that if you have a high absorbance value, you have a good binding. So first you discuss the value, how much. Okay. And then you tell the story. Those finding proof that the atomer could recognize and bind the target antigen. Okay, this is not something very important to you. But first, the steps is you describe the results. Okay, whether the absorbance going up or going down, and the interpretation of the absorbance. Okay, so a high absorbance value, the interpretation is high binding. So you have to tell the story, and you can put some this further discussion probably by supporting with some theory, or you have support with previous results of others. Okay, so let's go to another one. Surface modification. Because surface modification sometimes it is more relevant to all of you rather than the electrochemical. So, but I want you to observe this. Okay, the first one, he's talking about the electrochemical characterization. Okay, let me move a bit, right? So here there is, some of you, I think, has done some electrochemical work in the lab, okay? So there is a cyclic voltammogram. So here he tried to explain the CV, and you can see there is chemistry involved, okay? Because he's using diazonium salt. So this is good, okay? Means that you know your chemistry, okay? So you have figures, and it is supported with scheme. So scheme is when you when you put this kind of things, yeah? This is called schemes. Okay, so you are trying to propose what happened during this process. Okay, so not going to explain detail on this. Okay, let's move on to, okay, this is more relevant to you. Okay, because many of you will use FTIR, whatnot. Okay? So as I mentioned, FTIR is to prove functional groups. Okay, so now you can see he started with the explanation of the FTIR spectra. Okay, all right, let's move. It's not so much. There's not so many of functional groups. Okay. Okay. So you just zoom in what you want to tell. Okay, here he wants to highlight the CO stretching. So you talk about the CO stretching, whatever that you think relevant to your explanation that you want to highlight. Okay, so the conclusion, this result suggested that a new layer comprising carboxylic functional groups corresponding to 4-carboxyphenyl diazonium. So he tried to prove that the diazonium salt that he wished to modify on the surface is there by looking at the carboxylic functional groups. Okay, so how is by showing before and after. So FTIR spectra of bare means that no modification, and B with modification. So there is a significant changes in the functional groups. Okay, so this is very simple FTIR. If you might be using, you might be doing some more complicated FTIR. So you have to be able to describe the spectra, the peaks, the stretchings of in the FTIR spectrum. Okay, XPS, I'm just showing. Most of you don't do XPS because it's quite expensive. So this one you can prove carbon, oxygen, and also as I mentioned just now, nitrogen. I don't know whether he has nitrogen or not. XPS is actually a bit complicated. Yeah. All right. Just move on. Yeah, this is XPS results. Okay, let's look at contact angle. All right. As I mentioned, contact angle, if you haven't heard of contact angles, you can see contact angles of A, which is bare, no modification, and B with modification, diazonium. So you can see this is hydrophobic surface. Once it is modified, is hydrophilic. Okay, that is contact angle. Okay, it's quite easy, but it's very useful to prove the changes on the surface. Yeah. All right. And some explanation. You can see there's a lot of explanation. Figure demonstrating hydrophilic behavior. The angle reduction was reduced by the formation of strong hydrophilic oxygen, because he wants to talk about the diazonium is already attached. So diazonium salt is supposed to be hydrophilic. And he further explained why, the water angle seems to lower. It's about surface tension and all that. Okay, so this is not really a rocket science. It's just simple explanation. Okay, let's look at if there is any other. Okay, let's stop there. Let's look at another example, which is more relevant to you. Just a moment. Yeah. Now, this is the second example of thesis. So I want you to observe first the flow chart. That's okay. The first one is more on not to analytical technique, more on electrochemistry, which is not related to many of you. The second thesis is more morphological. It's more on material and morphological and some spectroscopic. So you can see here from the thesis, from the chapter 3, you can see part 1 involves synthesis, and there is spectroscopic characterization. I believe that some of you has taken atomic or atomic or molecular spectroscopy. I'm not sure. Okay, and there is morphological and structural. So structural is FTIR, morphological HRTM and FISEN. So we look at how the discussion on these types of work. And then part 2 This is more on parameter study. Yeah, we look at it. And part 3 is more, yeah, there is docking and in vitro drug release. Yeah, we'll look at it if it is relevant. Okay, so remember part 1, part 2, part 3. Let's jump to chapter 4. Okay. So chapter 4, again, the candidate has started with overview, which is good. Okay. Tells about what is being discussed in chapter 4. So you can see started with the synthesis of fluorescence probe just now. Okay. Means that the material being prepared. The characterization of the material involve UV fluorescence, and then next one is on the she didn't mention about HR10 FISEM, but there is it should be here okay. Some zeta potential particle size analyzer, because she wished to prepare nanomaterial. So particle size analyzer is very important. And zeta potential is for charges. Okay, what kind of charge material that you want to prepare. So using zeta potential, you can know the charges of the material. Okay, now is this, which is part 2, I think, is more on the RSM, and part 3 is on the computational, followed by the slow released. Okay, so I would like to, because this is something not observed in the first example, so it's good to look at, let's say you have UV results. What do you discuss usually in UV results? That depends on what you want to highlight. Okay, so similar structure, you present your result first. You can see that figure 4.1 is mentioned here, but it's a bit far. Okay, it's a bit far, but it's okay. Still acceptable. Not 5 pages, I mean, after you mention, but at least 2 or 3 pages, sometimes it is acceptable. It is acceptable. So look at how the results is presented. Okay. Okay. The aim is for people to be able to understand the results. Okay. So here the unit. Okay, the y-axis should be right. The x-axis should be right with proper units. And here the use of color is very distinct. You can clearly differentiate the blue color, the orange color, and this is what we call as legend. Okay, this is caption, this is legend. So because you're not sure what this color represents, so this is what legend for. So the blue color is for material zinc sulfide, and the orange color is for the second material, which is mangan zinc sulfide. Yeah. All right. And then the caption here, figure 4.1, A, UVV spectra. Okay, obviously it is UVV spectra. And B, tuck plot. Okay, I don't know. I actually don't know. This is for energy. For zinc sulfide and mangan zinc sulfide. So from the results, we can know that there is some shifting. Okay. If you add mangan to the zinc sulfide. So let's look at the discussion. Okay. So she talks about there is blue shift. Okay, because you have to explain the results first that you observe from the UVVs spectra. You talk about it, and then compared to undoped, okay, here, and this indicate, okay, from there you explain what is the meaning of the results. First, describe the result, and second, what is the meaning of the result, similar to what the first example is. So this indicates there's effect of quantization and alteration because of the doping process. Remember the doping, this is undoped, this is the doping with mangan. So there is evidence of quantization from the UV-vis spectra. Okay, so I don't know whether she is able to, but she's able to talk about there is a smaller size from the from the UV-vis. But another highlight here is how you put equation. Okay, so if you have any equation in chapter in discussion, okay, you have to make it proper like this with proper numbering, and the equation must be using maths equator, maths equation, maths equator, I think, in the minimum in the words. Yeah, I don't know any other way to do it, but the maths equation is in words. You have to properly use. You cannot just put using words, but you have to use the maths equator. And the symbol must be correct using symbols. Yeah, this is simple things, but it has to be properly written. Okay, this is another equation. You can see the numbering of the equation must be correct. Okay, throughout the thesis, throughout the chapter. Okay, all right. So let's look at another. So if you are, yeah, some of you has done fluorescent as well. I believe so. Okay, so now you have another figure explaining about the fluorescence spectra probably, and then give the meaning to the spectrum. Okay, so talk about the theory that Stokes shift. This is something that you have learned in molecular or atomic spectra, atomic spectroscopy. Okay. All right. Okay. I want to talk about the inset. Okay. So you can see figure 0.2, the caption, schematic representation for electron transition. Okay, blah, 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 blah. If you want to like put some extra information here, okay, you can put inset. Because this is pictures. So just to strengthen your observation. Okay, and you can see from this, you have a lot of information, like this is the original spectra, but this is the what we call as excitation, UV-vis, and this is what we call as emission, okay, emission of fluorescent, and there is explanation of how the fluorescent happen. So you can do this. You can also put some extra information in your figures. Yeah. Okay, let's look at another example okay, let's get this. Okay, so this is fluorescence spectra. XRD analysis, okay, I'm not good in XRD, but it's very important for material, because you want to, especially if you're working with metal oxides, okay, you need to evidence that the metal oxide is there. Okay, I'm not good in XRD, but this is very important characterization, and it must be evidence from the peaks. So the peaks are compared with standard angle. Okay. As I mentioned, I'm not good in XRD. All right. So let's look at any other relevant. Again, you have UV. Okay, fluorescence. Let's say if we have PSAM and HRTM. Okay, let's scroll through. Okay, I think some of you in statistic you have gone through RSM. So this is the purpose of having RSM, where you can study a lot of parameters at one time. Yeah, you can study a lot of parameters at one time. I'm not good at it. You can see these are multiple factors. You can study the multiple factors in one time. So that's the use of RSM. Yeah. And from there you can develop a formulation. Okay, let's. I'm not going to discuss RSM. Want to go straight to the, yeah, where is it? PSAM and then do we have it? Morphological analysis. Because sometimes people make, not to say make mistakes, but very important what you can discuss in morphological analysis. So here, first is HRTM. So straight away is the results. Okay, let's look at figure 4.11. Okay, so when you are discussing morphological analysis, okay, it's very important to give information on the magnification. Okay, the magnification must be there. If you want to make comparison, for example, you want to make comparison of different material. So this is what we call as carbon dots from natural resources. And this is quantum dots from metal, sulfide, mangan, dope, zinc sulfide. You want to compare, but you must be able to compare with the same parameter, meaning that, okay, if I want to compare 50,000, then I should have 50,000 as well for carbon dots. I want to compare 100,000, I should also have a result for 100,000. I cannot compare magnification of 50,000 for mangan, dope, zinc sulfide with 100,000 carbon dots. I don't have the result for 50,000. That is not, acceptable. This happens actually because sometimes, oh, I don't have the result for 50,000, so I just compare 50,000 with 100,000. It cannot be. You have to know if you plan to put comparison of 50,000, then you should have 50,000 for all the materials. Yeah. Okay, that is very important. So since this analysis is expensive, so you must be able to plan for it. Yeah. Okay. And the information must be there. The scale must be there. Okay. The scale must be there. If you present this kind of results, it's very important. And this analysis of the particle size can be generated from this machine as well. So it is generated from that. Okay. All right. So what do you discuss about HRTM? Okay. What do you actually discuss? Because HRTM, usually there's one purpose, is to get the size, to show the size. So, and that size must be evidence. One is from the scale. You can actually do this, or you can do this analysis. It can be generated, okay? So clearly, here the discussion is about the size. The average obtained 4 nanometer, okay? Luckily, it is in a good agreement with the UV result just now that discussed earlier in the thesis. And he talks about the distribution. Okay, it's all about the size. HRTM, okay, TAM is about the size. You cannot talk about functional groups, the chemistry, or the material, what kind of material from HR10, because it is not there. You cannot like, okay, I can see gold nanoparticle, I can see silver nanoparticle. No, you can only differentiate sizes in HR10. So if you said like discuss, there is a shiny gold nanoparticles here, then that is absurd. Yeah. So you must know what to discuss from each characterization. Right? All right. Now, that just now is morphology, but size. So another one is FISAM. Yeah? FISAM is another characterization for morphological, but this one is on the surface, roughness, porosity. Okay, so let's look at the results. Okay, figure 4.12. Okay, so you can see the difference. Okay, this is FISAM. Okay, so this is HR10. So HR10 size, FISAM is about roughness, porosity. Okay, you don't really identify sizes from FISAM, but sometimes you identify the porosity sizes probably. I don't know, but I don't think so. Okay, and another thing is you can, I don't think she have it here. From FISAM, there is what we call as EDEX analysis. If I can find the EDEX analysis, you can identify material that exists on the surface. Okay, that's FISAM. Okay, so let's look at the discussion for FISAM. Okay. Okay, the surface. Okay. Right. So let's look at. So from FISAM image, it is clear that all kinds of sun-based nanocarriers exhibit near spherical shape. Okay, shape you can discuss for FISAM. And the agglomeration, that if there is agglomeration, if there is a rough surface, if there is swelling effects, because it's morphological. Like what happened on your skin. There is redness, there is crooked. Okay, you talk about the what happened on the surface, what you actually observe, the morphology. Smooth surface, rough, porous surface. Okay, that is FISAM. Okay, and as I mentioned, if you pair the FISAM with what we call as EDEX analysis, then you can talk about what is on the surface. You may have gold, you may have silver, whatever that you put on the surface, right? All right. Okay, so same goes with HR10. Since she mentioned about she used the same magnification, so it's okay. You don't have to put the magnification, but the scale should be there. Yeah, the scale should be there. And sometimes there is another parameters that you put for FISAM or HR10 is I think it's the power. I don't have it here. Okay, let's look at another examples of FTIR. Okay, this is more complicated FTIR compared to the first examples. So you can see that, let's look at FTIR first. All right, FTIR spectra for a series of materials, okay? So she did some comparisons and she wants to show there is a different functional groups for all these materials. So you can see you need to highlight all the functional groups that is relevant. This is straightforward what you wish to highlight, but it's more is on the functional group, yeah, the chemistry. Okay, so that is how you discuss FTIR. I'm sure this is quite easy. Okay, you can have the table form as well. Okay, this is on the drug release study, so I'm just showing how the discussion is being done. An example, just an example. Okay, if you talk about pH, you have to talk about the chemistry. Okay, so I'm just showing that if you have results, you make sure that y-axis correct, x-axis with all the units, clear distinction, distinct color, and then you have legends, and the caption must be very, very descriptive, comprehensive. Yeah. Still, yeah, sometimes it depends. All right, what other things? Okay, all right. So one last example, all right. Okay, since this is, I think, probably different example compared to the first one. And the second one, this is water. This is removal of material development for removal of mercury. Okay, let's skip through. Okay, chapter 3. Chapter 3. Not yet.
Prof, in the meantime, may I ask a question?
Yes, yes, of course.
In the proposal writing for the assignment, does it come? I'm sure we do have a content list. Will it come with a list of abbreviations, list of tables, and all that?
No.
No. Okay.
But unless you,
Okay. Thank you.
if you have it, if you, I don't know, you know, that is for this.
Because based on
Mm.
FYP thesis writing previously,
Mm-hmm.
we did have like the format to list down all the abbreviations we used and the table and so on. So in the proposal writing, which is some sort of like a as a starter for the thesis writing as well. So I was wondering if I need to include it.
No, no, you don't put that
No.
in proposal, right?
Okay, thank
All
you.
right. Okay. Right. Okay, this one, there is no flow charts. Okay. But I would like to show some things here because what he has done a lot of material development. Okay. And sometimes you have difficulty. Let's say you have done a multiple temperature, a different sets of temperature. Okay, let's say what. I don't have it. I have it, but don't know where. Hmm. Okay, just look at it, this example. Okay, if you look at the words here, NC 500, NC MIP, NC cobalt ferrum oxide. Okay, so this is not standard, means that it is not like the name of the chemicals or whatsoever, but it's for you to name it by yourself because you want to tell people you have NC stands for nano, it's nanocellulose. Okay. Sorry. It's nanoporous carbon. Sorry. Okay. But it has to be explained before you put it here. Okay. So this is not the name of the chemicals, but it's the name of the material that you prepare and you name it by yourself. And you have to make it clear, make it in table form, the meaning of NC 500, NC MIP, this is something common, but sometimes people don't do that and it makes the reader irritated. Okay. because this is something that you create and you don't name it. So here, like for example, here the candidate is actually explaining that there is nanoporous carbon that he prepared at 500 Celsius, and there is another nanoporous carbon that he combined with certain chemical, and this is another chemical. So if you don't explain it earlier, then it's going to be troublesome for the reader to go to follow through what you are trying to explain. Okay, this is quite simple. But if you have a lot of material that you develop, let's say you have nanoporous prepared at 100, at 200, at 300, 500. So you have to name it and explain it first, the meaning of all those words that you created. Because you cannot like have nanoporous at 500 degree. Nanoporous because you need to use abbreviation. So that abbreviation has to be properly explained first. Okay. You may seem it's logical to explain, but some people don't do it. You get confused after sometimes because there's so many materials that you're trying to explain and you get confused. So you have to do that prior to your, especially in chapter 3 first. Yeah, you have to do that before you continue using the term in chapter 4. Okay. So here there are some other common. Okay, FISAM. We have done FISAM, right? And we have done XRD, FTIR. There is some other things that is also useful for you to know. All right, like TGA, okay, Raman, okay, that you can use for characterization of material. Okay, so let's look at other. Okay, all right, moisture content. So let's say you have some calculation. You have formulas and you have values from a series of calculation. But you do not want to show the calculation here, right? So sometimes the examiner asks about the calculation. So to be on the safe side, you should put the calculation in appendix. I never talk about appendix. Appendix is extra things that you find too many to be put in the original main content of the thesis. You put it in appendix. Yeah. Okay. So let's say you have the results of the calculations, and the reader or the examiner wants to see where's the calculation, where's the actual calculation. So you can put the calculation, at least some examples, in the appendix. Okay, it can happen. All right. So let's move on to chapter 4. If there is any other types of examples. Okay, you might have like TGA, okay? Because if you are working with polymer, TGA temperature is very important. Right, let's look at the results. Okay, this is preparation of the material, okay? So this is what I'm talking about. You might be using a lot of temperature. So you have the results from material, the results of material from different temperature. So how are you going to discuss the material sample 1, sample 2, sample 3? You have a lot of, so you have to put a name to it. So depends on you. You have to name your the samples that you have prepared. Okay, now let's say, so you here from the study of temperature, this candidate has found out that 500 is the best temperature. So the NC 500, which is the best nano porous carbon, from here, it is added with phosphoric acid. So again, how are you going to explain that you have NC 500 with 10%, NC 500 with 20%, okay? So those are skills that you need to explain first to the reader that this material one is what? NC 500, 10%, NC 500, 20%, okay? All right. Yeah, you can see here, okay? NC 500 and 100%, NC 500, 10%. Actually, I have difficulty reading this thesis, even though it is my students. To understand, okay, this sample represent NC 500, what is 500, what is 100%? Okay, so it has to be explained properly in chapter 3, okay? Right. Okay, okay, this is another very important characterization called BET. So anyone knows what is BET? The name BET. Anyone? This is the first question that I pose after 1 hour. What is BET? Not
Bruna Emmett Taylor.
Yeah, yes, okay, I'm sure. Okay, but yeah, the name is Bruno Emmett Taylor, but it is used to study surface analysis, surface area, and sometimes you can identify as well the pore size, pore volume, and this is very important if you're, especially if you're working with materials like polymer, okay? So here is very straightforward. You discuss about the pore sizes, the surface area. You want to increase the surface area because in this case, in this thesis, we want to capture more mercury. So of course, the greater the surface area, then that's what we want to, so that you can capture more mercury. Okay. Okay, so in BET explanation, this one, the absorption and desorption isotherms is very important. Okay, so I'm not going to talk about this, but I'm just going to show you the BET, and this is very important for characterization. And let's go to other things that you can have advantage. Okay, again, this is FTIR. XRD. Okay. I just want to highlight to you that try not to avoid to have a thick line like this. Try not to have it. Yeah, just use a thin line. Yeah? So you can see that this is not something nice. The font seems too big. Okay. So you have to make it nicer. Right. This is not something common, so I'm not going to talk about it. VSM. Again, we have morphology. So talk about pores. Yeah. So thermal stability, what do you discuss on TGA? Okay, second question. What do you usually discuss in TGA? Anyone?
percent weight loss against temperature, Prof?
Yes, weight loss. And why do you want to look at the weight loss?
Some interaction and something happen to the molecules. You want to see what happened to molecules when we introduce temperature.
Yeah, it's about thermal stability. When we develop materials, we would like to see whether the materials that we modify, let's say, with certain things, is it more stable, thermally stable compared to the original one, right? Because in certain application, thermal stability is very important because it's not always like we work at room temperature. Sometimes we have to work in extreme temperature. So in material development, this is very important. Okay, so here, okay, also I'm not good in TGA, but I do teach simple TGA. You have to look at the weight loss, yeah, mentioned just now. And then we have to compare like from the original material, whether we have greater weight loss compared to the modified material. Okay. Right. If you can come up with the whether the first is water or whatsoever, that's much better. But it's not always important because you're not doing what do you call speciation. You just want to know the thermal stability, right? So you can do DTG, yeah, if you need to, but please remember, you need to know why you do it, why you need to do DTG, why you need to do DTA. So you just don't simply do it. Please know the cause of why you do it. Okay, all right, I think that's it. Apart from what we have discussed. Okay, my last question to you. Because sometimes people do FTIR and also Raman, or sometimes you just do Raman. What is the difference between these two? Raman and FTIR. Anyone? Anyone has experience during doing Raman? Rahman, Raman. No one?
No, doctor. Never done
No.
ramen before, but PIR.
Okay. If you understand the I'm sure some of you have done, but silence. If you understand that when you run FTIR, so FTIR is about asymmetry or symmetry? I think some of you has learned FTIR before. Symmetrical or non-symmetrical compound? Okay, let's not talk about it. Okay, so FTIR and Raman is opposites. Okay. Okay, so I hope by now it's not just how to write thesis, but you have to understand the basic principle of each characterization. Yeah. Let's say how does Raman works, how does UVVs work, how does fluorescence work, because that's enable you to discuss efficiently. Okay. All right. Because you know the fundamental. I'm not asking you to know basically all the fundamentals, but you can read and you can understand, okay, how fluorescence work, how UV works, how FTIR, you have vibrational modes of the symmetrical, and then you have AC, it has to be asymmetry, yeah, for FTIR, and Raman is symmetry, okay? So you have to know all the fundamentals for you to be able to discuss more efficient in your chapter 4. That is a must. You cannot discuss if you don't understand the principle of the machines. How does it work? Okay, so I think if there is no questions, because I think Daya wants to discuss something with me?
Yes, Prof. After this.
Okay. Yeah. I mean, yeah, if there is no questions from everybody, so this is the last part for thesis writing. I have shown you some examples, real examples, how it is written. I hope that is beneficial to you. Yeah, let me stop the recording.